Hello, in this video we're going to look at an example related to least squares. And so the directions say for us to find an equation of the form y equals mx plus b fitting the data points given by these xy coordinates. Okay, so this is what we're given in the problem. And we've got data points like x equals 1, y equals 1, x equals 2, y equals 2.4, and so forth. And what we want to do is we want to fit an equation mx plus b equals y. We want to fit that to the data points. So we do know that when x is 1, y should be 1. And we might not get our model to fit the points perfectly, but this is what we would like to happen. So let's write that equation. M times 1 plus b, whatever that is, should give us y. And similarly, if we feed in our other x, y data points, we get a system of 4 equations. We have 2 unknowns, namely the slope and the y-intercept, which we call b. Let's put that in a matrix equation. We'll put this in that format. So this matrix here on the left-hand side, this is our big matrix, which we'll call A. The M times the MB, we'll call that vector V as in Victor. And on this right-hand side, that is our vector Y. And notice that A's got 2 columns in it. The first column of A turned out to be the column vector of X. So this is our X, and this is a big column of 1s, and I'll show you how to code that into MATLAB in a minute. Okay, so what our game plan is at this point, what we need is we need to solve the equation A times V equals Y. We need to solve this for vector v, because once we do that, that'll give us our slope, which is m, and our y-intercept, which is b. This is an overdetermined system. We have more equations than we do have variables. This is overdetermined, so we will use the pseudo-inverse of a. So here's how that will work. Vector v will equal, if we multiply on the left-hand side, essentially by that pseudo-inverse, we get vector v equals the pseudo-inverse of a times vector y. And so vector v will have some answers here. Whatever the numbers turn out to be, we will have a vector with 2 rows and 1 column, and we'll have some number here that'll be our slope, and some other number here that'll be our y-intercept, and that will determine the equation of the line that we seek. Okay, so I'm over here in MATLAB, and let's type in the data that we have. So we have a vector x, it's a column vector, and so I'm going to type it in as 1, 2, 3, and 4. And notice it is a column vector, so that's good. Vector y is 1, 2.4, 3.6, and 4. That's also a column vector. Now, we want to build matrix A. So let's say that A will pre-allocate the size, which is not that important. Our data is fairly small, but for larger projects, it's good to set up ahead of time. So A is going to be a bunch of zeros just to pre-allocate the size. It's going to be 4 rows by 2 columns. Now, in A, we want all rows first column, and that's going to be vector x. Next, we want matrix A, all rows second column. We want that to be a bunch of 1s. We want it to be a vector of 1s, which is 4 rows long and 1 column. I've intentionally left off the semicolon after a lot of these lines of code just so we can keep looking at the data we have saved in MATLAB. It's always good to kind of talk to the computer, make sure that the computer understands what you're typing in and you haven't made any typos. Okay, so now we've got A, we've got our vector y, and so we're going to let v equal the p inverse, the pseudo inverse of A times y. Okay, so recall that the slope we'll call it M. That was in our first component, so let's pluck that out. M equals V, whatever entry sitting in that first component of V. And our y-intercept, which we call little b, that's going to be V of 2. Let's plot our data. So to plot the dots, let's do a scatter plot of x, y, and see what we get. Okay, now that's a scatter plot. The only problem is the dots are kind of hard to see. They're kind of small. They're not filled in. So we can do a much better plot than what we have. So let's get rid of that and let's try again. So if you look in the MATLAB documentation, there's a lot of different commands you can use to control your plot, and I'm going to use a few of them here. So the first one is x, y is our data. The next number you can put in there, that's your size of the marker. Then I'm going to put in a marker, edge, color, and I'm going to set that to be black. And then I'm going to do a marker, face, color. I'm going to set that to be cyan. And let's see how that looks. That looks much better. Okay, so let's hold on to that plot. Next, I want to plot the linear model that we've developed. We already know the slope, we know the y-intercept there, and so what I'm going to do is I'm going to feed in some x mesh points, and I'm going to start that off at 0, move it up in increments of 0.01, and I'm going to end it at 5. Now we're going to plot x mesh points. Okay, so those are going to be the x points. We're plotting them very finely, so MATLAB will make a nice line for us. And then the y coordinates, remember that's going to be m times our x mesh points plus our y-intercept, which is b. And I'm going to plot this line as a solid line, maybe in blue. Let's take a look at our plot. You know, and that's pretty good. We have a pretty nice plot here. You could certainly go in here and use the GUI commands to change the line width and make it look a little bit more attractive. You can also look up the documentation, see how to do that with a line command. But overall, this shows how to use least squares and pseudo-inverse to find a decent model fitting through these points.